In two previous videos, I explained how to trace household wiring to your outlets using a voltmeter, a power bar, and a heater. And then in a second video, in the second of the two, I briefly outlined the theory behind why this method works. Today, I'd like to bring these two together and give you a worksheet approach to figuring out the organization of your house wiring. So what I did was I went back to my dining room, the same location I used in the first video, and I measured all of the voltages and all of the heater positions once again, just to make sure I had them all down correctly. So here is a table of the results. First, I plugged in the meter to each of the four outlets in my dining room, and I observed the same voltage, 121.4 volts. I believe this is slightly higher than in my first video. That might be because the electrical supply is a little higher, or there's fewer other appliances on in my house. Anyway, that was the baseline for today. And it is important that you, double check your measurements to make sure that hasn't changed throughout your measurement process. Anyway, I built this table. For each heater location, I'm just calling the four outlets in my dining room 1, 2, 3, and 4. They're the order that I showed them in the first video. For each heater location, as well as no location, no heater, I measured the voltage at each location. So with no heater, I got 121.4 volts at each location, as expected. If I got a different voltage at different locations, that would probably mean there was already a significant load on this circuit. Now I would go around and turn things off and unplug them until I got it at the same reading at each outlet. Then I plugged the heater into outlet 1, and I measured the voltage at all four locations. And they all ended up being the same, 118.1, or what's that, 3.3 volts less than the original no load situation. From that, I can conclude that every one of these outlets is downstream from outlet number 1. So outlet number 1, I'm going to use this notation. This says that outlet number 2 is downstream from outlet number 1. Outlet number 3 is downstream from outlet number 1, and outlet number 4 is downstream from outlet number 1. In general, when you plug the heater into any location, all of the other locations that experience exactly the same voltage drop, those are all downstream in one way or another from where you plugged in the heater. You don't really need to look at the upstream ones, but I filled in this whole table. Then when I plug into outlet 2, I see that outlet 1 falls to 118.2 volts. So it doesn't drop quite as much as it did when I plugged it into 1. But at 2, we get a considerably larger drop of almost 4 volts, 3.9 volts to 117.5. So this is as we would expect, because we know that 2, we already knew that 2 was downstream from 1, so this confirms it. 1 has a less of a voltage drop. If this was a larger voltage drop, we would have to redo our calculations or go check to make sure that the supply voltage hadn't changed or something. Anyway, that's as expected. So when I plug in here, the numbers to the left of where I plugged in, those are just, or that are upstream, are just confirmation. Okay. So 117.5 is what I have at when the heater and the meter are both at location 2. I see that location 3 has exactly the same voltage drop. And that, from that, I can conclude that 3 is downstream from 2, or 2 is upstream from 3. But look here, as number 4 actually has a higher voltage than number 2. That means that number 4 is not downstream from number 2. Number 4 must somehow tap into the circuit higher up or upstream of number 2 in order to get a higher voltage than there is at number 2. Okay, continuing on to the next row, I plug into position 3. And when I put the meter at position 3, I find that the voltage is 116.5. So I've dropped 5 degrees, 4.9 degrees. And I see that as expected, 1 is higher because we already know that 1 is upstream from 3. And also as expected, 2 is higher because we know that 2 is upstream from 3. And if you like it, 1 is higher than 2 as well, which is consistent with 1 being upstream of 2. So those are confirmation of what I've already concluded. Number 4, on the other hand, we see it is a larger value than number 3. So we can conclude from this that number 4 is not downstream from number 3. I guess we could have deduced that perhaps from the other facts we learned, but we can write that down as a fact that we have learned from this row in the table. When we plug the outlet into position 4, it drops to 115.2. What we learned from this is that, well, nothing is downstream from 4 because there's no other numbers that are equal to 115.2. And this is consistent with the fact that we already know that 4 is downstream from 1. And it's also, these are also consistent because what this means is that since 4 is downstream from 1, and 2 and 3 are also downstream from 1, this indicates to me that 4 actually taps into the circuit at the same place as number 1, because it pulls down number 1 and it pulls down all the rest with it. If it was attached to 2, it would pull 2 down more than it pulled 1 down. If it was attached to 3, it would pull 3 down. So we don't really learn anything new from this row in the table, but it's consistent with the facts that we've already learned. So that's good, okay? We know that 4 does not follow from 2, but I suppose the one thing we learn is 4 doesn't follow somewhere in between 1 and 2 either. Anyway, I can take all these facts together, and then I have a jigsaw puzzle. I have to do what's known as a topological sort, but just think of it as a jigsaw puzzle. I have all these facts that I have to incorporate in a diagram, and this is the only diagram that will fit. Number 1 is closest to the source of the electricity, so it's closest to the panel. We can't say for sure that's a home run. There might be other things in between 1 and the source, but there you go. We know that 2 is downstream from 1. We know that 3 is downstream from 2. We know that 4 is directly downstream from 1 and not from 2 or 3. So this is a picture of what our wiring diagram looks like. And if we wanted to put in a breaker circuit that would shut off all of these, we would put it at position 1. Now, maybe there are other outlets further up here that would be even closer to the home run. We don't know that. We only looked at these 4 outlets. As a matter of fact, I've done this for all of the adjacent rooms, including the living room and the kitchen. The living room has a half a dozen outlets. About half of them, one wall, are upstream of these outlets, and the other half are downstream of number 4. And in fact, I have an arc fault interrupter at the most farthest upstream in my living room. There's one outlet in the living room nearest the porch light, though, that is not connected to the same circuit at all. And again, you can figure that out because when you plug in the heater, that circuit doesn't drop at all. And while I was at it, I went to the other adjacent room, which is my kitchen. And I found out that the microwave oven is adjacent to 4. It's not downstream from 4. It's over here to the microwave oven. That wouldn't survive building codes today, but I'm going to pretend that I didn't notice that. I don't think I'm obliged to run a new wire just because I've discovered that the microwave oven is on the same circuit as my living room and dining room outlets and lights. That ends the third video that I'm doing on house wiring. I'm going to do one more and then call it a day. Thank you.